Good morning, Pre-Calculus. Welcome back from spring break. So we are doing lesson 8.1, part 1 today. It is about parabolas, conic sections, but specifically parabolas. Now you guys know what a parabola is. It's just that U-shaped graph, right? But technically, a parabola, let's say you have a point, all right? We'll call this point the focus. And say you have a line. Call this line the directrix. The parabola is supposed to be the set of points that are equidistant from the focus and the directrix. So this point here is the same distance from the dot as it is from the line, right? This point right here should be the same distance from the focus as it is from the directrix, and so on and so forth. All of these points that are the same distance from the focus and the directrix create a parabola. All right? That is your definition of a parabola. By the way, we're going to find all these different things here. We're going to find the vertex of a parabola. You know, the vertex is my point in the middle, right? There's my vertex. The focus was that point that I talked about. That's the focus. The directrix, like I said, is the line. The directrix, and the focal width is what they ask you for. The focal width actually goes through the focus, and it is the distance from here to here. Got it? That's your width. It's the width of your parabola, but it goes through the focus. All right, so we have these formulas up here, and I just put the ones that pertains to what we need today. So I have our vertex, the standard equation. This is the standard equation of a parabola. I have which direction it opens, the focus, the directrix, and the focal width formula. You notice that if the vertex is at 0, 0, that's that top sheet up here. If the vertex is at 0, 0, then, so say we had the x, y axis, and this was at 0, 0. Then our focus would be 0p, meaning that the distance from the vertex to the focus is p. It's always p. And then our focal width, you notice down at the bottom, is 4p. So if this is p long, then from here to here would always be 4p. All right? What are you saying, Miss Jones? Just show me how to do the problem. Okay. So, again, on example A, 8.1, we want to find the vertex, focus, directrix, and focal width of the parabola. I have, do you notice I have a blue side and I have a red side, okay? My blue side are the ones that start with x squared. And then my red side starts with y squared. We're going to start on the top sheet. You'll notice that if I'm looking at this formula here, x squared equals 6y, it comes from the top sheet. I know this because there's nothing subtracted or added inside parentheses. All right, it's just a plain old x squared. There's nothing taken away from it, so I'm looking up here. And x squared means I'm over here on the blue side. So I'm just going to follow all the set of instructions over here on the blue side. All right, so x squared equals 6y. The formula, the standard equation of the parabola is supposed to be x squared equals 4py. All right, that's my general formula, all right, the standard form. So that must mean that the x squared is x squared. I got my equals. Instead of 6, I have 4p, and then the y is the y. So what I'm saying is 6 is equal to 4p. I always need to find my p in order to find the rest of the stuff. So if 6 equals 4 times p, if I want p all alone, I would divide by 4, right? So p is 6 over 4, or we could reduce that and call it 3 over 2, or if you like decimals, we can call it 1.5. Whatever is fine with me. All right, so let's say that p is few decimals. Let's say it's 1.5. Okay, so the things they asked me for, the vertex, I said that we were on this top sheet, right? Because it was a plain old x squared. So the vertex for both the blue and the red, when it's just a plain x squared or a plain y squared, your vertex is 0, 0. All right? So my vertex, the vertex is 0, 0. Okay, focus. The focus on the blue side, the focus is supposed to be 0, comma, p. Y'all see that? It's 0, p. And my p I just found was 1.5. So 0, 1.5. Those are the coordinates of my focus. That was our point. All right, then I said the directrix. The directrix, again, on the blue side, the directrix equation is y equals negative p. All right, so that'll be y equals, oh, let me say what this is. We'll just abbreviate it. All right, so y equals negative p. Well, p was 1.5, right? So negative 1.5. And yes, if this p was already negative, then this would be a positive, right? All right, so there's my directrix. And then I want the focal width. The focal width on every sheet, all right? So here on the blue side, on the red side, whether I have things subtracted or not, the focal width is always the absolute value of 4p. It's always the absolute value, which means it's going to make it positive, right? If it's negative, it's going to be positive. If it's already positive, it's going to stay positive. But 4p. So focal width, I'm just going to abbreviate FW. And our formula for that is 4p, the absolute value of 4p. 4p is what I had from the very beginning, right? 4p was 6. That's where I started. 4p was 6. So it's just going to be 6. That's what the focal width is. That is what 4p was. It was 6. And I wanted to make sure it's positive, and it is. So that is A1, the vertex, the focus, the directrix, and the focal width. We just simply follow the formulas given here. All right, let's try A3. A2 was a star, by the way. That's why it's not up here, but it'll be on your sheet, and it'll be in Google Classroom. So A3, same thing. I want to find the vertex. This is different. This does not look like the last one. I have things that are in parentheses that are either added, well, they're added here. They're not subtracted. So what I am doing here is I am looking at this sheet, all right? Because I can clearly see that there are things in the parentheses. Again, I started with x. X is the one that's squared. So in this case, I am still on the blue side. I'll be looking down here. So what's happening is my vertex is no longer at 0, 0. My parabola is no longer at the origin. I am at HK. Now, H and K are actual numbers. We just have to figure out what they are. I want you to think, whenever you see HK, it's opposite X, opposite Y. Your vertex, and that's key. Your vertex is always opposite X, opposite Y. Opposite X, opposite Y. Opposite X is your H, and opposite Y is your K. And HK is my vertex. So in this case, my vertex, opposite X, and I say opposite because in the formula, you notice it's supposed to be subtracted, right? So if it's subtracted, but I actually see a positive, then what they subtracted was a negative, because double negatives make a positive. Just think to yourself, opposite X, opposite Y. So my vertex, opposite X, is -4. Okay, opposite X, that'll be my H. It's -4. And then opposite of what I see in there with the Y I see a +1. So opposite Y would be a -1. All right, and that is my K. We got that? Opposite X, opposite Y is your H and your K, which are your vertex. H and K. The other thing I said we needed to find was P. right? P. I am out of different colors, but the P is in here because according to the formula, just like on the last one, I have the x minus h squared equals, I have 4p. Whatever number is outside of your parentheses on the right is your 4p, okay? Well, not necessarily on the right, but the one that's not squared. So in this case, -6 is my 4p, okay? So if -6 is 4p, I find p simply by dividing, just like I did last time. So we'll divide by 4, divide by 4. And p is -6 over 4, which we can reduce. It's the same thing we had last time, except it's negative. So we can just make that -1.5. We'll hold on to that. P is -1.5. Okay, so I found the vertex. Now I need to find the focus. The focus. The formula for the focus, and again, we were on the blue side because I started with the x squared, right? So the formula for the focus is h, comma, k plus p. I want my h, and the second coordinate will be my k plus p. It'll be my k plus p. All right? And you do not have to write the formulas, but it's helpful. So my focus is h. I know what h is. H is -4, okay? So -4 is my first coordinate. And then I have the k plus p. The k was -1. So -1 plus, and p was -1.5. -1.5. All right, now of course I need to simplify this. So my focus is -4, and -1 plus -1.5 is -2.5. All right, so that is my focus. And again, we're just plugging in the numbers. We're just plugging in what we already know. What else did they ask me for? Directrix, the directrix. So the formula for the directrix, again on the blue side, the formula for the directrix is y equals k minus p. Y equals k minus p. Oh, I didn't do my color coding. Okay, it's very important that you have that y equals or that x equals on the directrix because it's the equation of a line. You can't just give me the number that you come up with once you do k minus p. That will be wrong, and I will mark it wrong because y'all know me. So make sure you have the y equals or the x equals when you're giving me the directrix. All right, so I have y equals, k was the number -1. -1, and the formula says minus p, and p was the -1.5. What happens when we subtract a negative? It becomes a plus, right? So it's actually y equals -1 plus 1.5. All right, that will give me y equals 0.5 or 1/2. Whatever floats your boat. All right, I found the vertex, I found the focus, the directrix. The last thing I need is the focal width. The focal width, I said, is always, no matter what side, no matter what kind, it is going to be 4p, the absolute value of 4p. So focal width, I'll just call that FW. And 4p, originally the 4p was -6, but the focal width is always the absolute value of 4p. So it means I'm going to make whatever number this was positive if it wasn't already so. So my focal width is just a +6 again. Remember, your focal width is the distance across the parabola, so you can never have a negative distance. All right, that's A1, A3. Shall I keep going? Why not? Let's look at what did I do? 1, 3, so 5. Because 4 is a star. hear y'all now. Ms. Jones, this is the longest video ever. Just fast forward through to the part that you need. All right, so A5, I give you 7y squared equals 20x. 7y squared equals 20x. What is this? This doesn't look like either case. I have a number in the front. That's not going on here. I don't have the parentheses, right? So I don't have anything subtracted. So I'm not on the bottom sheet. I am on the top sheet. I do have a y squared, so I'm going to be on the red side up here, right? Top red side. Now, I just need to make this look right. I need the y squared to be alone, but it has a times 7 in front of it. So I'll just divide. If I divide both sides by 7, then I have y squared equals 20 over 7, and I'll just leave it like that because it doesn't become a nice number. 20 over 7x. All right, well, I'm on my red side, top red side, which means that my vertex, when I'm on that top sheet, my vertex when I don't have anything subtracted or added within parentheses is 0, 0. The vertex for the top sheet, whether it was plain x squared or plain y squared, the vertex will be 0, 0. All right? Then I need my, I always need to find my p. Okay, well, I said that this right here is your 4p. Ugly. All right, so if 20 over 7 is equal to 4p, I need to divide both sides by 4, or we know that dividing by 4 is the same thing as multiplying by 1/4. Yes, because the 4's will cancel, so I could just multiply both sides by 1/4. All right, this will give me 1 times 20 is 20. 4 times 7 is 28. Or I could have reduced it right there, that 20 over the 4, and gotten 5. Either way, I'm going to need to reduce. So 20 over 28, they are both divisible by 4. 20 divided by 4 is going to give me 5. 28 divided by 4 is going to give me the 7. So 5/7 is my p. Okay? The focus on the red side. On the red side, the p is supposed to come first. It's supposed to be p, 0. My p is 5/7. So my focus is 5/7, 0. All right. And then the directrix. The directrix on the top red side, the directrix actually starts with x equals. It's x equals negative p. Okay, so x equals negative, and the p was 5/7. So negative 5/7. All right. It's a lot easier when our vertex is 0, 0. All right, and then lastly, my focal width. And my focal width is always the absolute value of 4p, and 4p is what we start with in the beginning. All of that was my 4p, 20 over 7. And it was already positive, so great, I'll keep it that way. 20 over 7 is my focal width. All right. That is the end of example A.